Hello, I'm Stuart Sutton, and this is my final project for cloud computing at Harvard University Extension School. Today we're going to deploy a Java application using Amazon Web Services Elastic Beanstalk. When creating web services and applications, developers often spend as much time working on infrastructure as they do on the code itself. It's easy to get hung up on a new technology where you might not know some of the installation procedures or how something works when you're using the technology itself. What a developer wants to do is work specifically on their code. They don't want to get stuck working with their permissions on Linux. Perhaps they got one small file incorrect and the whole thing won't work and they can't figure out why. It would be easier by an order of magnitude if developers could just focus on the code and all of the infrastructure were taken care of externally. Elastic Beanstalk is a framework that allows one to run an application in the cloud without having to set up the environment in which it runs. All infrastructure is created and maintained by Amazon Web Services. With this framework, a developer needs to focus only on the application itself. Elastic Beanstalk incorporates other Amazon Web Services offerings and manages them for you. For instance, you can assign triggers that scale your project up or down based on various circumstances. Although the triggers available with Elastic Beanstalk do not provide as many options as those available in CloudWatch. Triggers can be set up in the CloudWatch dashboard and used in Elastic Beanstalk. Elastic Beanstalk is an easy and simple way to choose your environment, we're going to use Java, upload, and run your code. For a Java AWS application, one can use a jar or a WAR file depending on the type of app. While cloud infrastructure allows for programming software as a service, Elastic Beanstalk provides the framework to create a platform as a service. What is platform as a service? According to Wikipedia, platform as a service is a category of cloud computing services that provide a platform for allowing customers to develop, run, and manage web applications without the complexity of building and maintaining the infrastructure typically associated with developing and launching an app. So, essentially, what Elastic Beanstalk does is use Amazon Web Services for you. Not only can it deploy and manage web applications, but it can run multiple versions of your app simultaneously. It supports numerous languages including Java, Python, .NET, Docker, PHP, Ruby. It also has numerous development stacks you can choose from, whether you need a regular Java server or you need to run on Tomcat server. It can use or interact with other services such as autoscaling, CloudWatch, and SQS. It can allow you to log into your EC2 instances, monitor them through the EC2 dashboard, and it even scales across multiple availability zones based on user set configurations. There are some limitations to Elastic Beanstalk. For instance, you can't attach permanent storage to your instances because the instances are populated and terminated in a moment's notice. Then this is all controlled by Amazon, so it's not something that you're going to be able to go in and add something to each of your servers that allows them to store information based on the application that's running on that hard drive. You're going to have to use your program or application to interface with some other type of storage. There also are no permanent IP addresses for these instances. While your project itself has a permanent address, you can visit it on the web, especially if it's a web application. The individual instances don't have that same ability. Also, you can't simply stop an instance and start it again later. This is all controlled by Elastic Beanstalk. It initializes servers when you need servers, and it terminates servers when those servers are no longer needed. The servers used in Amazon's Elastic Beanstalk are very, very temporary entities. So the problem I'm going to solve using Elastic Beanstalk has to do with Beanstalk Corporation, a fictitious company that we're going to work with today. BeanCorp needs to keep track of benchmark data created by their Amazon Web Services Linux AMI producer machines throughout the day and night. During business hours, many machines are active at any given point in time, whereas during off-peak hours, few or even zero machines might be running. The solution is to send benchmark data to an SQS Queue and read in that data to your Linux AMI, format it, and send it to a DynamoDB NoSQL database. So essentially there are three parts to solving this problem. We are going to use a couple of programs that we saw earlier in the semester. We are going to see the client-side producer and the server-side consumer programs modified specifically to solve this problem. The client-side producer program is going to do three things. Essentially, it is simulating Bean Corp's field computers. So if this corporation had internet-connected devices out in the field running these analytics, it would be able to communicate with their servers at home. However, we're going to be running both of these on the Amazon cloud, but for all intents and purposes, it is going to be simulating Bean Corp's field computers. Now, what the producer is going to do is it's going to create, as soon as it starts up, a unique server ID number. It is going to use that until Amazon terminates it. It's going to perform a benchmark method, which essentially runs some arbitrary code a lot of times over and over and calculates how many times it can run that code in a given period of time. And it's going to store that result and send it all the info, the identification, the result of the benchmark, and a timestamp to the SQS queue. The server-side consumer is going to potentially do 5 things, not all the same time it runs through, but there are 5 different things that it can do. It's going to create a database if one does not exist. It's going to hibernate for 30 seconds if no message exists in the queue. Otherwise, our application will initialize far too many servers and it won't terminate any of them. So we're going to let it hibernate if there is no work to do. It's going to read and delete an SQS message if one does indeed exist, format message data, and then it will update the Dynamo database with the data from that message. Amazon's Elastic Beanstalk does pretty much everything else other than fill out some forms and click some buttons. Alright, so now that we've gone over some of the things that Elastic Beanstalk can do, and we've seen the code that we're going to use for Elastic Beanstalk, or at least seen what the code can do, you can go ahead and dive into the code if you want. I'm going to be submitting it with this. But let's go ahead and take a jar file and turn it into a real web application. So here we are at the Elastic Beanstalk console. It shows us just some basic kind of stuff here. What we're going to want to do is go right up here to Create New Application and click on it. We'll give it an arbitrary name. Let's say eBean 1, 2, 3. First app. Alright. Click Next. And we're going to want to create a web server environment, not a worker environment. A web server environment is going to run the application for us, whereas a worker environment requires us to do a lot of extra stuff that we're not going to want to do right now. So create web server environment. The platform we're using is Java, regular old Java. And we're going to want to do a load balancing auto scaling instance so that Amazon will take care of some of the more robust issues that come along with initializing servers for our application. So we're going to upload our own, choose File, and we're going to go to elastic.jar. We'll click One Fixed, go to the next screen. There is not a lot you have to do after this. It's going to take just a moment to load, but really once this gets up, just enter a very small amount of information and Amazon's going to have our application running for us. We really are responsible for the code and not much else. So while that is getting started, let's take a look at some of the other stuff we're going to be using with our application. Here is the table we have titled Message Log. You can see there are no items in the table right now. Let's go over to SQS Management. Here we have 341 messages that I sent up with one of my producer servers. I shut it down just so we can kind of see how it's working here. and not have to have our application really keep up with it right now. Here are our running instances. I have a default environment from another application that I am running, but that has nothing to do with this project. We'll come back here in a minute and we'll be able to see some of the servers that it gets going. So we'll go back over here to create application, and now we're going to want to pick an environment name. The URL has to be unique, so we can just add some arbitrary stuff right here. Completely random. We'll hit next. We do not need any additional resources. Configuration details, you want to stick with one of the free tier ones just while you're messing around with it, not doing anything terribly serious, because that will cost you, or could potentially cost you, a significant amount of money. Use whatever key pair you like. Nothing else here is particularly important, so we will hit next. Again, we will hit next. Again, we will hit next. It does the permissions here for you. Here is our review, and let's go ahead and launch. Brings you right to your dashboard. And it shouldn't take too long to get going. So now our application is up and running. Our server has been initialized. Our code is uploaded and running. We can go over to the DynamoDB dashboard and we can see that it's putting all this information in. A receipt for a message, the number of cycles the machine's able to run in that particular time frame, the machine ID that sent the cycles in, and we've got the time it was sent. So a couple of different machines here are sending information to the SQS Queue, and our application is all putting it here in the DynamoDB. We can go to the SQS Management Console. There were 269 messages a couple of minutes ago. Let's see where we are now. 210. Took a few of them out. We can go over to the EC2 instance, and we will reload this and see what our environment has given us. Here is our instance running our application. So let's go back and see a couple of the other things that we can do. We'll go over here and let's go to configuration. Let's say we want to set some auto scaling. We're going to go to scaling here, auto scaling, fill out your information. This is pretty good for just testing out your application. The trigger here is what's important. I was using network out with an average. If you look at the documentation I provide with this, you can see where I made my mistake with my first build and how I was able to rebuild the application. Also, I can show you how. If you come back to the screen right here, so everything's running but there's a problem with your code and you want to run it again, you hit upload and deploy, version 1.2, choose your file, assuming that this has been changed, open it, and deploy. That's all you have to do to update your code. Just those steps right there. Everything else will remain exactly the same, and without missing a beat, without even having to take your application down, Amazon Web Services is going to be able to update and keep your application running smooth. It's really a wonderful piece of technology.